of all, what we'll do is I'll just talk a little bit about general stuff. You've got a booklet with the solutions in it, so if you can look up there every now and then, because one of us will say something and Val will be able to just play with the cursor to show you what we're actually talking about. The comments that we'll all say here are based on partly the markers' comments, who obviously do the marking because they're called markers. So they give us detailed feedback on how they found students answering some of the questions and how well they did. So some of our comments will be based on that information. I can tell you that overall, 1,198 people sat the exam, and that's through the international schools, and I can't tell you how many from there, who do the SACE program on our timetable, and the Northern Territory and South Australia, obviously. The overall results, I can tell you the graph for the scores, raw score out of 100, was negatively skewed, and I'm not going to teach you what that means. And the mean score was over 50%, and I don't have the authority to tell you exactly what it was. So, too bad, you don't know. So if there's any general questions initially, let me know, and I see if I can answer them. Otherwise, you'll get the answer. I can neither confirm that nor deny. So, question 1, here we go. This question was quite popular, and many scored very well. And in fact, 600 of the students scored full marks. So it was a lovely way to start the paper. The negative things we saw were that some students had trouble choosing the correct U and V dashed, if you were looking at the notation there on your solutions or up there. Mucked about with it and didn't get it out, unfortunately. But fortunately, oh no, it's not to show that. Okay, forget that. In part B, on the front of the exam paper is one of the statements saying, show appropriate working and steps of logic in the question booklets. So when there is a show that, it's really important for you to emphasise this whilst you're teaching. We must see steps of logic. So what we are looking for especially is that very first step from the integral with the square root and the squared. We really do need to see that rather than starting with the second line of working there. We also need to see the second to last line in some form or other so that they are showing us how the pi squared is achieved. They don't get pi squared mark because it is a show that. One thing I also want to point out is that, I should have said this at the beginning, that the website does have comments from, what's it called now? It's not called examiner's comments, it's called something else, to show you question by question, actual hints, what you should be seeing from your students and what a popular incorrect answer was or a popular way of solution. So it is really worthwhile reading those comments on the website about the exam, as well as the moderation information. Question 2, most students scored out of 6, 4 out of 6 for this question. The things that we saw well done in this question were A part 3 and B part 1. They were very good. A part 2 and B part 1, beg your pardon. And unfortunately, the answers for A part 1, the producing polar form for the complex numbers, we did see some students not doing that most efficiently, the most efficient way that they could given their calculator. Some students are still finding the modulus and finding the argument using tan, etc., etc. So given that it's 1 mark, we are expecting students to do it in a very quick way, and given types of calculators, the quickest way that your calculator will do it for you. A Part 2 was good, using the properties of cis, and B Part 1, as I said, the polar form was very good. In B Part 2, so this was most frequently the 2 marks that people lost. They missed the requirement that z to the n had to be positive, and the smallest positive value of n is 24 in this solution. We did find that a lot of students had forgotten from B Part I that they were looking at positive integers, so we did allow non-integer solution for that. But in theory, the n equals 24 is the answer. But it was accepted with the, I can't remember what it was without that. What?
Now that is to say that we weren't soft on these kids, though we do love these kids. It was because the way the question was set up is that we would have to accept the 24 on 7.
Yeah.
It wasn't that we
It was
were
24
being
7. Yeah.
popular vote says.
No, no.
Unlike every other subject, we do have a mark scheme that we try and stick to.
Yep. Yep. So question 3, the majority of students got 7 out of 7. So this was a very popular question. There are some issues here though with students setting out, that if they didn't set it out properly, they got themselves into a mess. And one of those things is using, instead of -1 to the power, in brackets, -1 to the power n, they used -1 to the n, which we all know is incorrect. They did get themselves into a muddle if they used that incorrect notation, even though they meant it. But as we're marking, we are not mind readers, and we can't allow seeing incorrect maths. Part B. Some students missed the second sentence there, show that there is only one possible value of n. So we are expecting to see that when n is even, there was no integer solution possible for n, yeah, you get it. And the last one, Part C, was very well done. Of course, there's follow-through marks. Yeah?
I've got a question. Part B says, Part A says if x plus 1 is a factor, okay, so that's equal to that or 3 or 5, if it's a factor. Then in Part B, you have to use the results from Part A, but it didn't actually say that x plus 1 is always a factor. It says if it's a factor.
Yep. And we did think about that, and we were ready to see that with solutions from students. Nobody had an issue. Every single student who answered this, they used p of -1 is equal to 0. So I acknowledge what you're saying, but from what we saw in their working, no student was put off by that, and the follow-through into Part B as well. You got a question, or?
I think the wording could have been a little bit better in hindsight.
Yeah, and I've said I agree with that. Okay, over to you, Val.
Now, this question, on average, the kids scored around about 7 out of 10 of this question, so they've done it fairly well. But when they're doing this sketch of this curve, I've sort of written a few points from memory. There's still a lot of students who don't draw graphs properly. They should, when they're using the graphics calculator, they should obviously use the scale that's provided in the graph.
She's very controlling, isn't she? She wants
They
to do
need to
everything.
make sure they keep t between 0 and 3 pi on 2, and they need to check the pitch. You get funny sort sort of, it's pixelated, I suppose. If you don't make the pitch, I think when I did it on the calculator, because I did it here, if you go to my view window, right down here on the pitch, it's 0.02. If that was changed, then that would, you know, they end up with just sort of random points and it doesn't give you the definition that you need. So the other thing that worries me about their drawing, they tend to look at the graphics calculator, see the shape and go, oh yeah, this is about like that. They should probably be using the trace function and actually plot a few points so that they get it about right. We're not looking for complete accuracy, but more than what a lot of the students are doing, and certainly not the sort of sketch like you do in art where you kind of do it like that charcoal type drawing. So and they should be doing it in pencil. So that's what I wanted to say about that. Those who did it well, it was fine, but that main thing is that they're just drawing a rough picture rather than sketching with points plotted. This part was fine, but the comments Deb made about the show that, same thing applies here. The answer is given. They need to be very careful. I've written X dashed and Y dashed. It'd probably be a good start. Obviously that wouldn't score any marks, but this needs to be very much itemised in here. If there was no answer, sure, they could go straight to that. But because the answer's there, they need to explain where it's come from. There's not a lot to say about the Y dashed, but there you go. This one here, same issue again, show that the length is, so it's given to them. They did make a bit of a mess. See the brackets I've got in orange? The students, their notation and their use of brackets is not good. And I think some of them were probably thinking, oh, that's either the 2T or they weren't quite sure how it had happened. So misuse of the brackets there meant they didn't always get that 101 into the 2T. There was a bit of fudging going on. And obviously they need to show this step here. And it is nice if students explain over here what they've applied at times as well. That's good practice for them to do. In this last part, make sure you draw attention to the fact it says, for a start, it just says calculate the length. It doesn't say the exact length, and of course it says correct to 3 significant figures. So when there's 2 marks, often one of those marks may be associated with that degree of accuracy. So if they wrote 8.749, they have not done the 3 significant figures. So do draw their attention to watch out for when it states the level of accuracy required. So no questions? Right, the induction question. And the average around this question was about half, so 3 to 4 out of 7. The bit that seemed to really get them stuck at the beginning was they saw that x can't be 0 or 1 and confused it with values of n. It clearly needed to be stated, so it had to be there, but they were starting off with p of 2. And that was getting them a bit unstuck. So that would be one thing I'd point out to the students, always identify where you are starting. It may not always be 1, it could be 2, it could be 0. And I think, yeah, it was mostly P of 2, wasn't it, guys? Yeah. Okay. Another thing that I've found, when they're doing P of 1, sometimes they just associate it's the first term, 1. So always tell them, if you're doing P of 1, go to the last term, which is 1 on x to the n, put in your 1 and you've got 1 on x. So your stopping point is 1 on x, so you're going to get 1 plus 1 on x. And some of them were a little bit confused with that left-hand side. Right-hand side was okay. They pretty much worked through that. As regards this setting out, it's not enough when you're saying PK is true to just write this bit on the right-hand side. They should be writing it out as a statement. The sum of these terms is this here. Some of them stuff around using sigma notation. It's not in the syllabus. We don't require it of the students. Don't bother with them trying to do that. Now when they do PK at 1, sometimes the kids are just focusing on this last part here and we don't see much mention of this. So just make sure they're kind of doing the whole bit. Then they've subbed in using PK, that was all right. A little bit of fudging, but generally this was quite well done and it came out quite simply. And they do all the writing that has to go there. It must close with that statement. It's part of the whole process of induction. You don't round it up and say that, you know, the first step you got onto, etc. It won't make sense.
Val,
The second part,
say that that statement is with the PN for the mark.
yeah. When we assign the marks, it's kind of no guts, no glory as well. If they haven't done the guts of this, they can hardly get, I'll answer your question in a minute, they can hardly get the glory of that final mark. That final mark is not just that closing statement, this bit here. They have to have stated what the proposition is that they are proving. So if they do not do P of N, blah, 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 then even if they've done this closing bit here, how can they be talking about P of 1 and P of K at 1 if they haven't said what the proposition actually is? So, now your question?
With respect to the sigma notation, even though it's not in the syllabus, if a student opts to use it, are they deducted any marks?
No, of course not. But we find that they get confused, and I know that because the textbook that most people use has it, a lot of people think, you know, oh, we've got to do it. So there is no, it'll never be presented with sigma notation. And quite often when we saw the students doing it, they were confused. So, pardon?
Confused you first time I saw it.
Yep. This second part, it wasn't that well done. I think most students, I mean, they're used to Part B sort of having a value that, you know, you've got to put in and whatever, and this one's a little bit different, which it's allowed to be. So they did that first bit where they've done what P of N is, but unless they could isolate out the 1.1, they really haven't sort of established why it is less than 1.1. And it is nice to acknowledge that what you're taking off is a positive number, because otherwise it'll be bigger than 1.1. So it was a bit different, but still used P of N. And that's me for now, and it's over to so you get your jokes now.
Thank you very much for your continued efforts. You know we are the defenders of the universe. We are the defenders of mathematics. Please take it careful when you go home. This is a dodgy part of town. I had to come all the way from the Southlands up to the northern part of the city. There's lots of traffic. Do be careful. Also, if someone says, "Psst, would you like to teach general mathematics? Would you like to teach essentials?" Just say that you have got a job maintaining wonderful standards. And there are some naysayers around there. There are some, in the cloistered parts of the city, people saying that we don't teach vector proof, that we don't teach differential equations. We certainly do, and in fact, question 6 was all about vector proof. Unfortunately, the first 5 questions were clear sailing for the students, average of about 70% each question, a little bit of a hiccup with a mathematical induction, but still going well. Question 6, vector proof, and kind of the kids have been doing this since stage 1, was a collapse. It was the worst answered question in book 1, and with a mean mark of about 40%, and kind of tragically, because when you have a look at the very first question to work out AB is equal to AC plus CB, over 10% of students couldn't even get a mark for that question. I mean, it sort of makes you cry that after 2 years of vectors, there was not a mark on the horizon. And in fact, the ladies haven't mentioned, every one of the questions in our exam has had a 10% no attendance rate for a mark. Every question had at least 10% of students who didn't pick up a mark for a question. And that's really quite sad because there are easy jump-off points or jump-on points for the kids. So that was kind of tragic. And please don't get us started. The poor markers, I got that many phone calls saying, what has happened to vector notation? The A with the little squiggle underneath. I mean, don't you get a little smile when you say to your kids, A squiggle or B squiggle? I would say, honestly, a quarter of our students didn't indicate that the term was a vector, it was just A and B. And maybe the gods, the mathematical gods up there thought, you want to play bad notation with vectors, maybe bad times will come. And in fact, from having this wonderful start of a mean score of 70% for questions 1 to 5, things started to drop off. In A Part 2, very, very few students got that PA is equal to 1 over k plus 1 times the vector A. Most just had 1 over k. And if they carried that on, they could still pick up some marks. But our students, bless them, and certainly they're not modelled by us, if they're given an answer by Jingo, no matter what they do, they always get that answer. But they would have been better served being honest and just working out the 1 over k. But the students collapsed in B. The vector proof of the half mod, the PA cross PQ, they missed out the k plus 1, but it suddenly magicked in the answer. And for most students, A Part 1 came up, C Part 1, and that was just a little substitution of plugging in k is equal to 4, and they're given A cross B. The kids got that, and the last bit, they could see that that quadrilateral was a big triangle, take out a little triangle. But the average mark for that question was only 4 out of 9, and once again, it's indicative that vector proof, and I guess because we only have a 2-hour paper, isn't it wonderful to have a 2-hour paper? Most other states in Australia have got 3-hour papers, but we have a 2-hour paper. So we can't examine everything, so vector proof kind of gets a Guernsey, not every year. But most years that vector proof comes in, the kids do collapse in vector proof. So that was a little bit sad. Question 7. Beautiful stuff. Engineering people love this stuff. Slope fields, solving differential equations, and the students picked themselves up again. The mean mark got to be around about 65%. We still had 10% of students who scored 0. I mean, how great is it doing slope fields? You know, it's like being in an English class and you say, man, how am I going to handle these kids? Silent reading. Let's do 2 hours of silent reading. We in mathematics, when the differential equations are getting hard, we just get them a slope field to line up. And the students love that, but there still were 10% who just didn't pick up a mark for that question. But the slope field was well done. They knew to start at -0.5. They sort of didn't infringe the slope lines. A few tried to go as high as 0. They should have gone down to -0.15, but it was still particularly well done. The differential equation was also well done, and it was a little bit different. Sometimes the kids find the separation, they're a little bit, they might have had y squared dy, and then they get themselves in trouble. But that differential equation was done well, and that whole question was done well. And even C Part 1, in which they were given another equation, our kids actually, we have got good problem-solving skills in Australia. We get criticised, we don't do this well, we don't do this well, but so many kids read, C Part 1, there's a new equation on the block, there's a new kid on the block, and they just plugged in values for that. And most students got Parts 2 and 3 correct. Part 1 was a little bit of a problem, but that was well done. That question was really well done. And paper 1, the mean mark was round about the 65%. Question 6 was a hiccup, vector proof, and as I said, vector proof keeps causing problems. Now we come to the money part of the paper. Paper 2, book 2, and kicked off with vectors. And what is there should we know about vectors? Dot product, cross product, lines and planes, but also there's systems of equations mentioned in the syllabus. And that has in the past, and even in fields further from the city than these local high schools, kids in the country tend to find the system of equations a little bit poor, and it might almost suggest that it's not taught or not well taught. But the first part was well done. Some students stopped at y equals 3 and didn't verify that that was the equation of the line, but most did pretty well. In A part 2, you had to state that t is equal 0 and t equals 4. And look, none of us would chastise our kids for not doing as much as they can, but they should have put the comment, oh, t equals 0, t equals 4 checks. I know they're rushed. It's a 2-hour exam. Well, it's really 130 minutes. But that they should make some comment, and the markers are being kind of generous, and I guess in the examiner's comments sometimes they say, well, look, what does your answer tell you? And the answer, t equals 0, t equals 4 checks. Try and make, and I'm sure you tell your kids to do that all the time. In part 3, that was quite well done using the normal and the direction numbers of a line and dotting them and getting 0. And if it's 0, that implies that they're perpendicular. Some didn't finish it off by explaining it once again, but we were kind of generous at the time. And there were still other innovative, adventurous students who plugged the equation of the line in the plane and they showed it was inconsistent, meaning that there was no solutions. So that was quite well done. So the first 7 marks was well obtained. Finding the equation of the normal, we forgave them if they used the parameter t instead of s in the haste of the exam. That was well done. You give them the point, you give them some direction numbers of the normal, and then that's where a little bit of the collapse came on, to show that that was the midpoint. And I know kids are rushing. Some kids actually found a vector AB. They didn't find the midpoint of AB. To show the intersection, some students missed out that showing that there was consistency in the values of t and s. And then some didn't, so that solution actually was the value that gave the midpoint. So, but there was a little bit of haste. But vectors should be a nice, friendly question. Certainly of the 15 marks, 10 of the 15 should be available quite easily. And then there's normally a sting in the tail, the very, to find the distance from L1 to P3. That was quite well done. You can just use the 2 points, or you could use the distance from the point to a line. Just be careful when you've got the equation of the plane, that when you swing that numerical term over the other side, you've got to change the sign. That sometimes is missed, but that was pretty well done. And then the last bit, is this the way that education is going to go? Are there SACE people? Well, no, ticking boxes. What's wrong with ticking boxes? Do we not like reading our magazines and ticking boxes and doing this? Well, here was a tick box question in part C. You tick the right box, eeny, meeny and miny. You get the right one, you got 1 mark, and then the other marks for the reason. And it was quite nice that those 2 triangles have got the same base, but the one with the greatest height was the one that had the greatest area. So the vector question was a fairly nice kick-off for paper 2. The mean mark was a little down on previous years, was just a touch over the 50%. but there was still more good times or maybe not so good times to come.
Okay. They started off here. This was well done because it's straightforward. So they could do it all sorts of ways, but it was well done by students. And overall, yes, it was not so good times because the average was down to around 50%, so 7 to 8 out of 15. Now, graphing. It's the issues as before, that they're not always plotting points and therefore they're sketches. You know, when it says sketch, that doesn't mean rough. Sketch is a term that's used to draw the thing, and they should be having some points so there is better accuracy in what they produce. It does say to label all asymptotes and the intercepts. The intercepts, as long as they're in the right, positions and the scale allows it to be read, would be okay. I just wrote them in again last night. But when they're doing these graphs, we're actually suggesting if you use two different colours, that's helpful. This part here where they're together, it might be useful to label that this is f of mod x and f of x as well, so that you understand the purple one goes right through, but the graphing packages put green on top because that was the second one that I did. So the asymptotes should be labelled and the intercepts be very clear. So if it says to do it, just make sure the students look at all that detail. And they actually needed that detail in looking at the questions that followed. And quite simply, the f of mod x, they should be looking for a mirror image of what they've got on the right-hand side there going around here. And that, I assume, would be the way most of you would teach it. So, yep. Now this part here, state the interval for when f of mod x is above f of x. You look at the graph and you see it happens between -1 and 0. And then they're equal because this was a strictly greater than. So some students said or equal to 0, which couldn't be included. And that was relevant to what followed in this part. So the students were reminded that mod x is minus x for x that's less than or equal to 0. But the wording up here, show that the expression for finding the area between the curves. Now, if it says the area between, you can't have an unbounded area, so it needed to be between 0 and -1 because even though it says for x greater than -2, because when you look at the graph, you can see that the area is unbounded here, so you can't work out an area between. And your attention was drawn to the fact that it was above, between there and there, and they should look for links between the questions because when they're written, they are all connected. I'm not sure Methods always does that, but pretty much Spec does.
Yep.
So when they did this question, again, misuse of brackets, not, like they're doing this f of mod x take f of x, because that's where it was above. The first bracket isn't absolutely necessary, but if they don't have this, it was miraculously being fixed up here, or they were putting a minus and just, that's what they meant, but they didn't write it, and if they didn't write it, they can't get credit for it. So it was misuse of brackets, and then they should show some working here to explain those two fractions, levelling out and getting that. They did do it other ways, made the algebra a little bit more complex, but those who did do it, did it reasonably well. It's just some didn't do it at all. And the last bit again, because it says show the exact value, there needs to be explicit steps shown, like this one here where you're showing what you're substituting in should be there. And there should be something to explain how the 3/4 got there. They could have 3 brackets, ln3, take ln4, but something to indicate what's going on in their heads with it. So does anybody want to ask any questions? So you'll finish it off.
Mm-hmm. Okay, this last question was very low success rate. Most commonly 0 to 3 was scored out of 15 for this one. The most common mistake in the first part was putting Z plus 2 in there. Students just did it wrong. They went left instead of right. Putting a Z in, it was their choice where they put it, but the first quadrant would always be my choice, and I never put, if I'm told to put a Z in anywhere, I never make it at pi on 4. So that would be the advice I would give to students. So some students, yes, had the Z plus 2 on the other side. Now, of course, there's follow-through marks. Explain.
Also put it on the imaginary axis.
Oh yes, some put it on the imaginary axis, which we couldn't allow again. In part 2, explain why. So we are expecting the words triangle inequality. I personally do what we've got here in the solution. I redraw my triangle. Every time I'm going to use a triangle inequality, I put it in my solution so that I can therefore show that I know the two sides and I know the third side, and that's the connection with part I. Part 3 was not very well done. We were not lenient, but we were pleased to accept any of the written responses up there. Again, it needs to be in context with the pictures that they've supplied or drawn in the part I. So we were looking for the solutions. Of course, we're talking about solutions for Z, how that would be equal to 2. We're looking for the equality of the triangle inequality to be recognised in some form of their explanation, their reasons we've given there. Not all of them, just something like that. Now, B part I, 1, 2 and 3, were really badly done. Even part 1, draw the set of complex numbers such that mod Z plus 2 is equal to mod Z, recognising that that is a line solution with x equals -1 was really poorly done. Marking a P on that line, it had to be ended up on that line, and having the imaginary part positive, so we needed it anywhere, that P would be anywhere on that line that is above the real axis. But in part 3, the Q had to represent the Z plus 2, so it needs to be horizontal to the real axis and 2 across. So it had to end at 1, and it had to be parallel to the real axis. In part 2, show that, and we're told they're seeing that angle POQ is theta. The solution supplied here is very nicely finding the modulus and the argument of Z on Z plus 2. There were a variety of solutions proposed by students here correctly that would have been fine. They didn't need to use the beta and the alpha as we've got here, and they did, some of them did very nicely with the geometric approach. That was the most successful approach, was the geometric approach. But unfortunately, a lot of blank attempts there. So C part 1, using part B. So they have to use part B, and it was given to them. So it was good to see that students used the show that and kept going. So that has actually, I think, been a positive and an improvement over the years, that students are using that show that more frequently these days. Part 2, C part 2, there are 2 methods here in your solution booklet. The most common approach was the one on the left. And at the final step, can you just circle that here? that one. At the root 3 plus I, all on that mess on the denominator, using calculator for that would be absolutely fine to give you that right-hand side. We were looking, therefore, for the steps there. We needed to see that they realised that that fraction did end up as you're given that, because it's a show. The right-hand side solution, not many students approached it this way, but recognising that the P, the OP, is your Z, the students managed to get through that way. C part 3, again, quite tricky. Some used the calculator with no or very little explanation, so unfortunately they weren't able to achieve marks for that. The picture here is an approach to be done, not working backwards, and very, very few people attempted this part of the question. So a high, have you got your stuff here? Yeah.
You mean
The data? You got your data booklet? Sorry, I'm just trying to see this one. Yep. Yep. I can tell you that about, 254, I'll just say it out loud. Nobody heard me say that. Students got 0 for that question. Remembering there was 1198 doing it. So that brings us, is there any questions about number 10?
6 got 4 marks.
Hey? 6 people got full marks. Yes?
Part 2 from 40. I'm just curious why there's 2 parts to it.
A part 2.
Because it's like 1 half study from 40 and 1 half the drawing.
There had to be some recognition of the triangle, either by a drawing or by words. Yeah, 2 sides of a triangle. The 2 sides Z, mod Z and mod Z plus 2 are longer than or equal to the 2. Some version of that, yes. Most of the students would have drawn a triangle. Yeah. Any other questions? Nope. As a closing off, Dennis, you might want to say something at the end as well, I don't know, your usual stuff. Carmen did mention the subject outline has changes, so please, please, please make sure you're aware of that. And Val and I are doing a session, and part of our session we've produced a table showing you old section, what the new section looks like now. So it's a nice comparison, so you don't have to have your 2 documents going what along the way. So the other thing is that I think Carmen mentioned this, that you are allowed to use 5 SATs instead of 6, but please, please only do that if your students as a whole have been compromised in a single SAT. You can't say, Olga didn't do well in SAT 6, Dennis failed SAT 2. So you can't pick and choose which SATs you're not including. And you really should not discount, you shouldn't make the student sample smaller just because you can. Please play by the rules properly, and if they have been compromised by a big hit of illness, or you have, or something happened at the school, then do break it down to 5. You can't leave out the investigation. Damn it.